So now we discuss more advanced topics of arrays. We actually discussed some of them here, so we already discussed all of that, how to define an array, how to access its elements. So something that is, I mentioned briefly, is in the C89, we said you cannot define a variable size of the array. So you cannot say int x and then use x as your limit size of the array, right? In later versions of C, you can actually do that. So what you can do is you can define a variable, integer for example. It has to be integer because it will be the size of the array. And then you can use this as your array limit. Good? So the storage that you reserve in the memory. For example, you need 30 locations, then you define int x equals 30, and then you use x. Good. Okay. So to access the array element, we already discussed this as well. So one thing, I guess you guys know this by now, the index of the array should be larger than or equal to 0. You don't have an index of array that is a negative value, right? Here you are defining an array of double that has sizes of 6. So that means its elements are actually from 0 to 5, right? We start indexing in C from 0. For example, it's not like MATLAB where you start from 1. And it's very important to know. Good. Okay. Something you cannot do in C is you cannot actually do math operations or assignments into the full array. What is the reason for this? Is actually the array, and this is very important to understand. Assume that this is I remove this, but assume I have an array here, right? That has, I don't know, like 3 elements. And then this array is named A, right? Actually, the variable A in the compiler is a pointer to the first location of that array. Because remember we said array is a data structure that gets stored in a contiguous place in the memory, right? So we have A0, 1, 2 are all actually on the same location in the memory, starting from address 0, for example, up to address, if this is int, you take 4, 8, 12, right? Good? So this is a contiguous place in memory, and the name of the array is a pointer to the first place. So when you say A0, what actually the compiler does is adds nothing to this pointer address and go to element 0. If you want to access A1, the compiler knows that A is an integer. That means each index is 4 bytes. Good. That means you should take the address itself of A. I'll give you one example because this is very critical to understand. Assume the address of A, this address, it's 0 in the memory, similar to what I have mentioned here, right? So if you access A0, what does the compiler do? Basically, it takes the address of A, which is 0 here, and then adds the index to it. And I know that actually each element of the integer array is 4 bytes, so you multiply the index by 4. That means it gets you address of 0 and go to this place in memory. What if you want to access index 1 or the second location? How the compiler would know where A1 is located? A is the name of the array, but also it's the address to the first element, and then adds to this 1, which is the index, multiplied by 4 because it's integer, and that means you have to go to address 4. Address 4 would have the first element of the array, right? This is basically how a compiler knows where to go to access each index. Good? And this is very important to understand. So if you have any question, let me know. Good. Okay, so for this, yeah.
What if we don't define the size of the array there, right there, if the array size is not?
You cannot have this in C. In C, you cannot have a dynamic size array, right? You can do this using other things like pointers and other things. But for this specific reason, you need a specific size of the array to store in the memory. Remember when we said arrays for the first time? We said array has to be, all the size of the array in the memory has to be allocated at once, at the beginning. So if you need 4 variables, like an array of size 4, then you store 4 multiplied by like the integer size, which is 4. So you need 16 bytes in the memory. So you cannot have a dynamic size array in C. Good? So would you say this again?
I have some examples before where they did not define the size of the array.
In C, it has to be a pointer. Let's discuss this afterwards. It has to be a pointer, right? So maybe you just open some of the examples and let's discuss them together. Good? Okay. So basically, for this specific reason, yeah.
Yeah, you can, what he's saying, you can do that if you declare all the elements, like if you specify the values for all the
Oh,
elements.
initializing them. Ah, okay. I see now what you're referring to. But by initial, this is what you're referring to, like saying A, for example, equal 0, 1, 2, something like that. But this, as you can see, implicitly defines the size. It's telling you that you need an array of 3 elements, right? This is a way of initializing an array. But here you don't need 3 because actually this tells you it's 3, right? So you see the point, but you still have a fixed size array. Good? Thank you. Good. So now the thing is, because A is not referring to the array elements itself, A is referring to the address of the first element. You cannot say A equal B, right? Because for the compiler, A is nothing other than a pointer, right? So you cannot assign a pointer to another pointer by using this assignment operator. Good? So this is a syntax error in C. If you don't fully get the science behind what I just said right now, what you need to know is you cannot do operations on the full array at once. You need to do this on element by element. This is the important thing to know. Doing this is not allowed. By saying, for example, A, I don't know if you have an example here, but by saying A0 equal B0, this is allowed, right? Because the A0 is nothing other than an integer variable, for example, right? So assigning one element of the array, a value is allowed, but assigning the full array something by logic is not allowed. Good? So yeah, comes to your question here, there are some ways to initialize the array. One way is basically put all the elements of the array here. So that means you define an array of 6 elements. This is element 0, 1, 2, 3, 4, 5. Good? Here, you basically only initialize the first 4 elements. The remaining ones are not initialized. And by nature, they are actually initialized to 0. Good? This is what you were referring to, right? You didn't specify the size, but basically the number gives you the specific size, right? So here you still have a size, an array of size 4. But this is an extra information that may be not needed. For example, I can omit the 6 from here. The reason is that the compiler looks into the initialization, count the variables that I have, and then define the array to accommodate for this number of variables. Yeah. By elements, again. So you cannot have, and thank you for the question. Again, you cannot do math operations on the full size of the array, even if they are the same size, right? It may seem natural to you, but the compiler doesn't know this, right? And as we will see later, actually, C compiler, when it comes to arrays, it even have more stupid things, right? So we'll come into this. So one possible way, for example, here we initialize the array by actually giving all the variables, of all the variable values of the array. But that's okay if you have 6 elements, 4 elements. What if I have an array of million elements? I cannot just write the million variables, right? It doesn't make sense. What can you do to initialize this? Is you can do this within a for loop, for example, right? Here what we do is we initialize all the elements of the array to be 100, right? So we define an array of 40 entries, and each entry gets 100 value. Good? So this is very clear to you, I guess. This is saying less than or equal to n minus 1. This is less than n, which means you stop at n minus 1. These are just different ways of writing the array. The important thing to know is in C arrays, you should start from 0, and the index stops at the size -1, right? Because if you have an array of 5 entries, those 5 entries are 0, 1, 2, 3, 4, right? Which is 5 minus 1. So if you have in general an array of size n, the index is from 0 to n minus 1. And this is the reason why we either have n minus 1 with equal here, or just less than n here. Good? We already had this in our example and quiz, where you can actually read the value of the array from the input user, right? So there is no to be discussed this. So this is a syntax error, and the reason for this is we define 6 entries in the array, but we actually give 1, 2, 3, 4, 5, 6, 7, right? So the compiler will not accept this. This is correct, but this is a syntax error. A reason? Again, you cannot have the full array as one of the operation or the expression sides, but another reason is actually this is one index. You say, basically here you define an integer array of D, 5 elements, but you cannot say D equals C for the reason that I mentioned earlier, right? You cannot perform operations on the full array. You need to specify this one by one. What can I do to actually get the value of C to D? Yeah, you have a for loop that goes from 0 to 4, and then you say DI equals CI. Then C0 will go to D0, 1 to 1, etc., etc. Good. And this is the stupid thing that I was mentioning about C compiler with regarding to arrays. One big limitation in C, and I guess I said this in the first lecture, is it doesn't have actually a good memory garbage collection handling thing. What does that mean? Is basically, because it's a low-level programming language, it gives more control to the user. This is good, but again, it's risky, because you have to handle everything yourself. One of the things that you need to handle yourself is actually C compiler doesn't have a boundary checking for the array. What does that mean? Assume I define an array. I need 2 minutes, okay? So I hope you stay quiet for the 2 minutes to get done.